Hello everyone. So the next example will be, let's say language L1 contain set of all strings which starts with A and our given alphabet is A comma B. So if I consider all the strings in a language, then in each string the first symbol or the first alphabet is A. So how can I construct such type of language? So the possible string will be A, AB, AA, ABA. Okay, in each string the first letter is small a, because here constraint is the language the string in the language should always starts with A. So let's say I will draw the DFA. Capital A is the initial state. If I start with A, then I will go to some state, let's say capital B, and capital B is the final state. Okay. On final state, I can accept any number of A's or any number of B's, no problem here. Why? Because I already started the language with small symbol A. And what happens if I see a small b? Because I consider the small a and small b for capital B state, but I don't consider the capital B, small b for state capital A. So if I see a small b on capital A state, then I will go to some state, let's call it as a dead state. So if I see a small b, then I will simply reject the string, and on small c I can take any number of base or any number of b's. So this is the minimal DFA for this language. Okay. Let's say language L2, set of all strings which contain A. So if you draw the DFA will look like this. Capital A, let's start with a initial state capital A. If you see A, then you will go to a state, let's call it as a final state, and final state will contain any number of A's or any number of B's. But what happens if you see a B at the start of a string? Then you can simply accept such a string, because in the language it says that it contains A. Okay, so if I see any number of B's from the start, then I will simply accept. After that, any number of A's will come. I will also accept the string and I will go to the final state. So this is the particular minimal DFA for this language. Okay, so you can start with small b and then after take a transition on small a and then finally go to the final state. Let's take language L3. Language L3 ends with A. So set of all string which ends with A. So ends with A means you can start with initial state capital A, and if you see a small a, then after that you would not see any B on final state. So if I see a small b, then I will go to final state, and on final state I will accept any number of A's, but I will not accept any number of B's. So if I see a B, then I will go back to the initial state capital A. Okay, and here also if I see any number of B's, then I will simply accept it. Okay, So the language will be constrained that it will always ends with a. So any number of a's is possible, single a is also possible, but the string which ends with b, simply we come back to the initial state, and then after we can take the another move. Okay, so this is the language which starts with a, contain a, and ends with a. In the next video we will see some other examples related to DFA.